So slow.
Edison, can you just tell us what you're doing?
I download the code and show how it takes a long time. Oh, damn. So just wait for a moment. It takes a long time to download the source code.
It's coming, right? Here. That's from 2 nights ago.
2 nights ago.
That's the whole tree from 2 nights ago.
That's okay. I just wait for it. Let's see.
I don't trust networks to work when I need them.
Maybe I can copy. Into folder.
That's the, yeah, no, that's going to have a bunch of Git trees under it, so
Ah. This one?
that's the top level. Yeah.
This is faster.
Are you on access or access 3?
Hmm?
Are you on access or access 3? Your
Access.
wireless.
Access.
Yeah, try to connect to access 3 using your regular password. This is unknown. You just have to use the, just connect to it.
Current header.
Yeah, access 3. And use your regular username password.
I tested yesterday, so it's fast. Right.
Yeah, I don't know why it's taking so long.
Okay. Let's see. Maybe faster.
It's going to start from scratch now.
Sounds faster. this one. Where I'm coding. That's faster. I can't pull the bits. I just use this one. Can't wait to download. So this is a new code I copied from last 2 days ago.
Didn't work?
But I can't pull.
Huh. That's weird.
It's okay. You can just use 2 days ago code. So we have the code. First, we can add the code into Eclipse. Import Edison project. CloudStack. No. So finish. Okay. So we import the code, then we have everything installed. We have Java, have Tomcat, and then we can build our code. Clean. We run compile and build, and clean and build, and deploy server.
Question for you while this is building.
Okay.
Did I see you sort of ignore the build errors that were within Eclipse back there? Because I remember when I first brought this code into Eclipse, not in this, but actually in Eclipse itself. So in the Eclipse project.
Sorry?
In the Eclipse project,
Okay.
there was usually when you import this code, there's a few errors. Were you just ignoring those? You don't care about them?
In the Eclipse here,
Yeah. So see the red tags on your,
this is let me see.
or do you just not try to build within Eclipse?
Let me see what's it coming from. Maybe this is because of this guy.
Yep.
This guy has some.
But this is something everyone has to do if they want a
Yeah, I
clean
have some
Eclipse. That's why I'm
dependency.
wondering what Citrus's practices are.
How to fix that?
Hello?
No, because we can just delete, remove, fix the issue. Right.
One question here.
Mm-hmm.
Yeah, before you remove those from the build path, can you just walk through these different modules and give a quick overview of these individual
Okay.
projects, right?
So you mean for the each project,
Yeah.
what they are doing? Okay, we can introduce the code. So this project, the agent code is for the we have some agent running on the KVM host and running in the system VM and concept VM. It's a the Java process, the separate code running on the KVM host and the system VM.
So this agent is the one which you deploy on the hypervisor for the KVM.
Yeah.
So
For
if,
KVM.
for example, if we are working with
If
VM,
you look at code, okay, you can find maybe KVM code in here. KVM code is in here, and lot of KVM code. And almost for KVM, it's agent code. So this one, agent simulator, is for the simulator. So we have a simulator that you can, you don't need to have a real hypervisor. You just need the simulator running as acting as a hypervisor. So today we will show you how to use a simulator and to add the simulator host into managed server. So in that way, you don't have any kind of a physical host to create a VM.
wow,
Yeah.
okay.
And this part API is for all the API. You can see for all the CloudStack API module is here.
So this API has the API would say the northbound, southbound, if you will. For example, you have the kernel exposes certain API for the say for the web interface, for example, right? So this API consists of those classes. Also, the API that is exposed to the agent side, I mean the resource side, also is there.
This API is for all the CloudStack web service API, RESTful API.
No, this API contains both the web services API, contains all of our integration APIs, the plugin APIs, and contains all of the agent commands that are sent to the resource.
Actually, can you pull up yesterday you have showed the architecture diagram where you have all the modules, logical pieces laid out?
Right.
Maybe we can, right?
Yeah, he has to pull it up, so I'm not sure he knows where it is, but I can answer any questions you have in terms.
Okay.
Yeah, we mentioned yesterday that there's a plugin API, where for example network element is a plugin API. That interface would live in this package here. But at the same time, there's also the web services API, all the actual agent APIs that get sent to the server resource, those are all listed in this package.
Oh,
Okay, we go to another one. The build is for the Ant build script. Usually don't need to touch that. The client is for, what is client? Oh, the code here.
Yeah, so what you're looking at there is the configuration for the Tomcat client and to deploy our servlet for the client directory.
This one is for console processing. So
That's the Ajax.
yeah, Ajax.
Yeah. This is the proxy between the hypervisor and a user's computer to allow the VNC viewing of the actual VM, and that runs on a VM that we start up and allow the VNC images to be proxied over so that you can view it over Ajax.
So is that just a Ajax VNC, or are you guys doing a translation into whatever is necessary for the end?
We actually do translation. So what we do is we take, we act as a VNC client and to the server, and then we take snapshots of that frame buffer, and we change it into bitmaps that gets transferred. So, but I don't know if you've seen our UI, but in our console proxy view, then it looks like it's actually, you're actually moving your mouse and things like that. But it's actually a stream of bitmaps that gets sent and down to the viewer. And this way, you don't actually need an applet or anything like that to actually view it.
Cool.
So everything in that project lives in that VM, completely separate from the core.
So the core project is a foundation of the CloudStack. There are a lot of the infrastructure code here, the hypervisor code, network.
Edison, I think you need to be a little louder.
All right.
Speak up.
Excuse me, please. Small question. Your core runs inside the server, correct? Your core runs inside the server. That's correct?
So core today contains all of our server resources, except for some of the KVM. For example, KVM should have been this core package,
No.
because but it isn't. Edison.
The hypervisor.
Wrote that.
Yeah.
But the core package is meant to be deployed in both the management server and an agent container, which is the container that you saw earlier. So can you scroll back onto the agent? And in this agent up here, other than the KVM resources, the majority of things that's in this agent is nothing more than a Java process that says, I know how to load up the resource from a configuration file. So you put in the configuration file and says, load up so-and-so resource, and it will instantiate it and load it. And then this agent is responsible for serializing and deserializing the JSON, and then pass the Java commands down to the resource. So the resource itself does not need to know how to request the message.
Question back here. On the management server, back here in the corner.
Hi.
On the management server, is everything running in Tomcat, or do you have standalone Java daemons that run as well?
On the management server, everything does run within Tomcat. But you have to understand, for the CloudStack system, the resources do not necessarily have to run within the management system. They could be running on a VM that's located in the data center where your resources are. And that VM actually connects out to contact the resources. For the entire stack, it's not necessarily everything is in management server.
I had a question. So yesterday on the architecture diagram, we saw the kernel. Is that represented by a project here, or is that?
Yeah, majority of the kernel would be under the server project.
server. Server part is
And you can see in the server project, that's where our DAOs are, because
Very
that's the only place where you're supposed to actually talk to the database. Nice.
how about the usage?
Yeah.
The usage, usage server. Utils is for the utility. This project for VMware.
Yeah. Can you hold on here for 1 minute? So, for example, VMware and OVM, those two projects, we are, I mean, the picture that I drew up yesterday is the vision that we're trying to achieve, and we're moving toward that. The problem is that, we started off a much smaller project, and there are a lot of things that's in the existing. And OVM and VMware are two of the newer resources we added to CloudStack, and they much more behave as what we think the packaging should look like. And so these guys are basically their own jar files, have their own build, and then you just deploy the jar files and load the resource. So they're separate from the server side or the core. What we hope is that eventually core would be completely broken down into different projects, and each project would be like send server hypervisor or KVM hypervisor, things like that, and then each one have their own jar, and we use the compilation boundaries to enforce the fact that we shouldn't be putting logic across the projects.
Okay, we go through all the code.
Can you run this client in a debug mode right from Eclipse? I think that would be very useful for actual learning the system also.
Yeah, I'm not sure if we could do that. I know one person in our team actually knows how to do that. But it is possible from our build to do and debug. But once you deploy the server, then you can do and debug, and then you can actually attach Eclipse to that, and everything will work as if it was running inside the Eclipse project. Yeah. And we're going to show that today, right?
Yeah. So this guy built it down, and now we can deploy. First, we deploy DB.
A question about the deploy DB. Do you usually start from a clean database as you're developing, or do you kind of put in some template data so you don't have to start from ground zero?
We usually start from a clean database. We're going to expose some scripts to allow you to say, hey, this is how I want to set up my database each time, so that you don't have to keep doing it through UI or something like that.
I add another environment. Password. Build again.
Hey, Edison, did you change any of the build properties?
Yeah. I did add the database root password.
Okay.
Then I can deploy database. So the deploy database will initialize the database and create the table database table for the cloud. You see, for cloud usage.
So if that database is not brand new and clean, is it doing drop tables or anything like that, or?
That's right.
It is.
Yes, it is. The deploy script would drop all the tables first, and then we build them. Yeah, so now it's creating the indices and stuff like that. Takes about a minute. I once put an SSD card in, and it takes 4 seconds.
Okay, then we can run our server on debug.
I think I scroll by really quickly, but there's a debug port at 8787,
Yeah.
and that was
Say,
then you can attach Eclipse to it and actually run using breakpoints in Eclipse and things like that.
Can you maybe talk a little bit about why you chose to do the database initialization from within Java instead of from SQL scripts? Is there any sort of train of thought of using the DAOs?
Actually, it is just scripts.
Oh.
It just we just run it through Bill so that you don't have to go find it. Yeah, I think you're right. There's some pre-population. I'm not sure if there was a schema. Is this the UI?
yeah, UI.
Not it.
Okay, it's you can use localhost 88 to connect to the main server UI. So the password is the admin and the username is admin. The password is the password. Then you log in. Okay. So it's a welcome UI screen. So today we don't have a real host to add into the CloudStack. So this UI doesn't work. Click here. You can say the UI. Maybe, do I need to introduce the UI? Okay. Okay. This is a normal setup. Usually, if you have a real host, such as a real server, real VMware host added into the CloudStack, you set up like this one. But today we don't have the real host to add into the CloudStack, so we use a simulator. Deployment of a simulator is a little bit different than this setup. I need to shut down the main server and did some configuration at first. So there is a wiki page on how to set up the simulator in CloudStack. So we need to change some configuration file. Usually so you follow this step. Okay. There are setup DB. All right. Simulator. Replay this guy to simulator.
Actually, Edison, can you explain what you're doing here? Because I like to know.
Okay. So
I actually don't know myself. I haven't played with the simulator.
So this one we need to tell the CloudStack when you deploy the database, you need to deploy the database for the simulator. The simulator database is a little bit different than the normal database. So this is I copy the template, the simulator to override the template, the SQL. Another one is we change the component spec. So this one will tell management server when you load all the components, you need to load the simulator approach. You need to load the simulator components also.
Can you do a diff between the regular components.xml and the simulator component.xml?
Replace file. That's the only difference. Yeah.
No, but what about between the two XML files themselves?
Template.
So I think in our implementation, the simulator actually writes to another database with its own tables, basically to reflect VMs and things like that that's in. And so we need to create those set of tables as well.
So what's the difference? We have a new component XML file. So
Yes, I think it's under Tomcat.
component simulator.
No, I think you can just diff between components.xml and components.simulator.xml.
Yeah, I can't find the component. Where's the agent? Oh, yeah. Actually, they are different. They are. Let me see what. Totally different. Actually, so you can find from the simulator. There are a lot of components for simulator, such as the simulator group, the simulator discover. This is the. So we tell management server when you load all the components, you need to load the components related to the simulator.
Actually, can you bring that back up? Yeah. So a discover in CloudStack is a piece of code that understands exactly which resource to return to the management server. When you do an add host in the CloudStack API, you're only passing it a URL. And the URL is passed to each one of these discoverers, and whoever says, I understand how to parse out that URL and return a resource, and that's the resource that we think it has been discovered. And that's what these discovers are. We are phasing these out. We had these before, mainly because we didn't have the idea of a pluggable service before, where each of these plugins have their own API that says add a simulator host. So we used a common API. I pass in and use the variation in the URL to tell us what type of host you want to discover. In 3.0 and on, because of the pluggable service, you would be able to expose a add simulator host or add send server host instead of a common add host. But the simulator hasn't done yet, so it needed to add this simulator discover. And for the hypervisor guru, that's another interface that you can actually implement, and it is specifically, obviously, for hypervisors, because for each different hypervisor, there might be data you have to massage before you can start a VM. And so then at the start of a VM or stop of a VM, we will send it to the guru and says, this is the information that we think we are passing to the hypervisor. If you need to massage that data, change it, and then that's what we're going to send to your resource. So this is what I meant by each plugin is really two parts. There's logic on the management server that can do changes to how management server thinks a VM should be, and then there's the resource underneath who actually knows how to change that into the actual hypervisor calls. And that's why you see this here. There's a simulator guru, there's a simulator discover, and there's actually a simulator resource. But since that's returned by simulator discover, it didn't need to be specified to CloudStack itself.
I had a question on that. So you're saying that Discover was phasing out. So is it that for the non-simulator VMs also you're phasing it out, or is it just for simulators?
Yeah, simulator is just another type of hypervisor resource for us. So we are phasing it out for basically everything, and because there should be ways for you to say, oh, I want to add an F5, and the F5 plugin will say, this is the API I want to expose. I'll add F5 rather than everything go through add host.
Okay. So I think we are done. Yeah, then we can build our source code again. But when we build, they're a little bit different. I need to build all with similar. The build all done, build a similar code. Okay. Say compile simulator. Okay, then we can deploy database again. Deploy DB with simulator. We say that here I use the override template. This way, we create the template. This SQL have some entry for the simulator.
I see that Java process you're talking about. So I do remember this Java process. I think to your question about is it always just an empty database to start with? At one point, we had the idea that there's an XML file that everyone can put their configurations in, and this is a Java process that populates the database with that data. But we have moved on now to we should do this everything through our API, because it's actually easy to do it through API. And I think the script just left that process in there. At this point, I think the database is actually empty when we deploy.
No, that's new. Okay, then we can debug run line server. Binary test. The UI should work. So we have another part of the code that can automatically deploy the host for the simulator. So from the UI, you can add simulator host because the UI is not aware of the simulator code. So if you want to create a zone, here you want to add a host, but from the UI you can only add the real hypervisor host. You can't add a simulator host, so you must go through the API to add all the kind of thing. So we have a what's it called? We have a separate the Python test can that can that have a script to do all the kind of thing. So we let me show you how to. So we are in a tools test can. There is a bunch of Python code. So what this Python code can, you give him a description about how many zone, how many pod, how many storage pool, how many hosts you want to add into the CloudStack. Then he will call or the CloudStack API to create the zone, create pod, create hypervisor host into from the script. So that will. So you don't need to write API. So we can show you how to run this Python code. First, we go to here, top level. There is a build API docs.
Yeah, so this is actually a little bit different. And what Edison is showing here is the Python client stubs to our web services API. And you can build these because in our API documents, we generate our API documents based on the annotations that we have in our web services API classes. And so then it's a very uniform description. And then you can actually generate Python stubs from that. Can you actually show how
Yeah.
how it relates?
So this is we generate what API description in the XML file. So all of the CloudStack API is in this XML file.
But this is generated, right,
Yeah, yeah.
from what you just did.
Yeah.
Yeah. And how does it actually look get that generation? Where is the source that I get it from?
So generate the XML file.
Yeah, the actual source of all the parameters and things like that.
There is a API docs. Writer. Yeah, it's got.
Oh, you're showing the code that actually does the generation, but where is it grabbing that information from?
We grab information from. Let me see. Or API command. I think it's in a. Build.
So actually you can go back to that, go back to the file. So it's actually grabbing them from our Java files at that point. And the Java files are in the API directory. We can pull one up. Can you go back to Eclipse? So in Eclipse, pull up deploy VM command.
Deploy VM.
Yeah. Okay. So this is a web services command that we have. This basically defines the incoming request as to CloudStack. I kind of showed that off a little bit yesterday, but we can go a little further down now on these annotations. And so each one of these with a parameter gives us an idea what these what parameter that comes into the REST call should map to these particular member variables. So for example, it says, oh, the name is zone ID, the type is long for zone ID there, whether or not it's required. And can you pull up the XML file then?
So deploy. Yeah.
I think there's a capital.
Okay.
Yeah, so that deploy VM command actually maps to this particular phrase in the REST API, deploy virtual machine, and then the zone ID XML file is all generated from those annotations. So as you make changes to these command files and add these annotations, then you run a deployed, what was that, build doc? When you run that build doc and operation, then this XML file will get regenerated. And then I think our doc writer also make use of this, and then that XML file actually gets translated into our API docs for that release. So, and then on top of that, then the Python test stubs is also generated from that XML.
Is there any way that
Excuse me, do you generate this XML file from compiled code or from source code?
I believe it's from compile code. I didn't actually write it, but either way, it would have to be generated from the build. So.
From the class file. I read all the class file.
Yeah, I think it looks for everything that has the CMD or from a certain package, and then it just lists those out.
So we have to build first.
Yeah.
is the REST API versioned in any way?
I don't believe so. Yeah, that is something we're hoping to add in.
Okay, so we get all the API description. And we put this file to something else. Then we want to generate the Python binding for our API. Okay, this is Python header. There is a code for the code generator. They can read the our XML file. Then we'll generate all the Python binding. So you can generate the code in here in the CloudStack API. We can go through it. Tools, test current, refresh. Okay, you have found. Okay, so we have found the deploy. Maybe we found the deploy VM.
Just deploy virtual machine.
Okay. You see, okay, this is room ID, right? It's a description of what's the room ID, and it's required or not. So when you write the CloudStack API code, you just look at the code. You can find okay how to write, what's the parameter mean, and what's the is it required or not. You can find all the information in a Python binding. So after that, we can.
Hang on a second there.
Okay.
So it's required, but you're setting the value to none, or what am I missing?
I think that's just the initial portion,
The-
the initialized value.
Okay.
Yeah.
Do you do checks before,
Yeah,
do you do
I-
checks against that?
Yeah, I did that.
Okay.
So because you say I have there is the list. So if it's required, I put all the required element in here. So if you call the API, you didn't specify the required element, I'll return error.
No, if it doesn't return error, CloudStack API should return error then also, so.
Yeah. Okay. So next we need to generate the description of the how do you deploy the setup. So first, literally you need to have a one zone, one pod, one cluster, and one simulator host. So here we have code called the configuration parameter. Look at here. Configuration. Config generator. So this code is where you can okay, here is I show you some code. So we want to it's some code we generate the setup for the advanced zone. Here you can create a one zone, in the DNS, internal DNS, in the name of the zone. And you just describe in the Python code. I want to create 10 pod here. Only 2. What's the gateway for the pod? What's net mask? What's the IP?
So is that creating 10 pods or 2 pods?
That's 2. And with the description,
Yeah, okay.
yeah, it's an error. There are two hosts. So here they're different. So for hypervisor host, so you need to specify in this URL format, HTTP-sim. So you will tell the managed server, this host is a simulator host. It's not a real host. Yeah, 2 hosts. Then I want to add 2 parameter storage for each cluster. This is just primarily just any kind of a path for the parameter storage, and we want to add 5 secondary storage. I want to add a public network. Okay, now I did also description. Where is the managed server? What's the IP address of the managed server? So here we use the local host. Where is the database? It's localhost, right? Okay.
Sorry, why do you need to know where the database is?
Because the Python client, because the Python client sometimes he want to access database directly. So if in your test case you can directly access the database.
This is to verify that
Yeah,
things
verify
has
some
worked.
test. Verify. I mean, maybe if you call API, you want to verify the database is changed or not.
I see. I see.
So it's some log file. So I can show you how what it generated. So right now in the master code it's only working with the run zone. So if I run the code, generator. So here read from the just out the no input. So you say it's a JSON file. It generates a JSON file. Just have all the information about the zone, the pod. You say the cluster. Right now the cluster, the hypertype is the simulator. How many hosts in the cluster? For each cluster, we have 2 hosts. We have 2 parameter storage. So we have 2 clusters. this, okay. This secondary storage, we have 5 secondary storage. Yeah, we have a DB server. We have a logger. We have manual server. If we'll have all the information about our setup, then we can deploy the setup. There is another code called deploy listener. So this guy read from the config file. Then he will call the CloudStack API to create all the information based on the config file. So actually, what I did is, so if you want to create a zone, right, you need to call the CloudStack API to create a zone. So we can, so the manual is running, right? So we can run this code. So a bit about. I show the UI. You should have something. You say you have one zone to create. There are 8 hosts is being created. There is the host. It's a simulator host. Oh, let me see. One zone. So you have a system VM running, or Slack running. Now, 2 parts. Each part have 2 clusters. It's a simulator, hypervisor is simulator. So each cluster have 2 hosts. It's up state. So actually, we can create a VM from UI. Say, it's a simulator template. This way, see, it's within camera. Test. Then the VM is running. Okay, so basically, all the operation from the UI should work in at this stage. You can create volume. Test. Camp. I see. Okay, so right now we have set up. We add the simulator host. So next we can call the CloudStack API to write some test case to show how the framework works. Let me see. So so next we can show you how to write some test case against the Python client to show how to write the test case in your code. So we have bootcamp. I create a folder and I create a file. First, the Python code. It's Python. Okay. write the Python module. The test code. Okay. Okay, there's nothing here. We can copy some file. So basically, we can write test case in the Python code. What this guy is doing is this test client use the Python unit test framework. So what you need to do is you write a class based inherited from the CloudStack test case. Then you write a test function, and then you get API client. So what API client doing is it can call all the CloudStack API. You see, it's a deploy VM. If you want to deploy VM, if we want the list account, they call all the CloudStack API. It's very easy to use. So right now we can write some API code. How about we want to create a VM in this test case? Okay. So first, if we want to create a VM, we need to get to know what's the room ID, what's the template ID, and we need this information. So we get the information from the API call. First, we get the room ID. Get room list rooms. Now this guy. So if I don't know what the parameter should I use, we just go to the API description. So if I want to get a room, there is no required. Okay, if I don't input anything, it will get all the rooms. API client list room. Okay, we get all the rooms. So I just want, right now we only have one room, right? So the room ID should be rooms ID. There need to be a trick. It's a list. So here we get the room ID. Okay, then we get the default template ID. Template ID. The same thing. Get template. List template. So what kind of parameter should I use? I don't know. So this guy, the template filter is it's a must. It's a required. So I need to pass down template filter. To refer is a feature. The hypervisor. The simulator. Okay, we get the template. Template. API client. List template. Okay, so we there only have one template for the simulator. So we get template ID. Template the ID. Okay, then we can create a VM. Create a VM. have room ID, temporary ID. Yeah, we need a service reference ID. Sorry. Get the service reference ID. So what kind of information should I provide? Nothing. So how many service references should I have name? Small instance. So we just want to get a small instance, service reference ID. Get the user system. Echo force. Spells. Service reference. Okay, I should have a service reference ID. Return ID. It's only one. Okay. So we can create a VM. So create a VM. Deploy. Deploy virtual machine. So what kind of parameter should I pass down? We need a room ID. The template ID. We need a service reference ID. Okay, so I think we are done. VM equal deploy virtual machine. Okay, so we can print the VM. Okay, we write down the test case, and we can run the test case. There's another code called deploy and run. So this guy take the config file, what we did before. Where the test case, it's a bootcamp. It's a folder of all the code. That's my code in here. Okay, the log file. The test case. Test case. Here we just only load the config file because we already deployed the setup before. So we just -L. What this guy will do is he will execute the this test case against our setup. So let me show you how that works. So here we only have one VM, right? After we run this command, it will create a new VM. You see? It's a new VM is created. We have created a new VM. It's very simple, easy to use. So we can go on if you want. We can create the volume and attach the volume to a VM. Create the volume. Okay, that's a little bit complicated. Create the volume, we need to get what information we need to know. before you create the volume, we need to get the disk buffering. Disk buffering. Get disk name. Small. What kind of disk buffering do we have? Storage. Storage buffering. Disk buffering. Really small. Get disk. Disk buffering. So it's a disk buffering ID. Okay, we create a volume. Volume. Disk buffering ID. Create volume. Name. Give it a name. Test. Long ID. Right. Disks. Alright. Wait, volume. Okay, when you want to attach the volume to a VM, attach volume. Attach. So we need the disk ID. We need the VM ID. Right. We can call the API. Attach volume. Okay. So we are done. We can try it again. Okay, we can show the it's correct or not. We can get the result. It says we attach the volume to a VM field because I don't. We need to figure out what's wrong with the attach volume to a VM. So how we can debug this situation? Okay, usually we have a log file. You see here is a null pointer exception, right? So we can add a debugger here. Where is the exception? It's a user manager info. User manager info. What's the name? 557. So I don't know why it's an exception. Okay, we can add the debugger here. Then we attach the Eclipse to our manual server. Debug. Okay. The Java application. The localhost. The port is 8787. Localhost. Proceed. patched, right? So we run again. You see? So we get here, say why is there exception? Well, this guy is null. Okay, usually why this guy is null? So there are some bug here. First in the inject. So actually you have no why we need to inject there. Sure. And another one is Java. I
Wait,
guess
did you do that on purpose, or is that actually in our code?
it's a code here.
Really?
Yeah.
Dang, that's horrible.
Because that guy, I don't know who what the code. I mean, it's another one is where is the default component library. They didn't add the DAO here.
Oh, you're working off the trunk?
Yeah, master.
Ah, okay.
So that's house is
Still.
rolling house DAO, right? So we add a DAO. So before when the Windows run managed server, they will load all the DAO into the managed server, but need to tell the managed server which DAO he need to load. Maybe that guy, didn't do that kind of thing. Okay, so we can continue. Right. First, we need to shut down the debug. How to shut down the debug? Let's see it. Debugger. Okay, go. We need to, so we change the code, right? Then we need to redeploy. Okay, we run the managed server with the new code. Okay, retest again. So, hope it works. Okay, we see the result. Yeah, it's done, it passed. Yeah, so we find the bug and fix the bug. Okay, so there any question about?
Hi, I had a question. What type of automated builds or testing do you have against trunk or any of the branches?
Sorry?
Do you have like automated functional tests or unit tests that run at some periodic interval?
Yeah, we didn't roll out. I think we didn't test it in the master branch. I did.
Yeah. We actually have people writing the automated tests using this exact same process, but I don't think they're done yet. I think we have about 87 test cases so far, and more. No. Answer? Actually, what is part of our QA?
So yeah, I think it's being integrated with Jenkins right now. That's where it's at. So hopefully there'll be nightly builds being tested.
Have the unit testers come in yet, or is that being run with the nightly builds? Do you know?
I'm not too sure.
Is there any questions regarding this? Any comments on what more we can do? Can you open up actually the database tables and take a look at those?
Database table. Which table you want? What?
Both the simulator tables and the
Okay.
and the
Show
class.
tables.
Like, so is all the mock tables yours, the simulators?
It should be. Why is it here? It should be in a separate database. Okay. Show database. Interesting. No, it should be in a separate database.
Okay, but those tables belong to the simulator, yes?
Yeah.
Okay. Can we take a look at those?
Okay. Host. Yeah.
And these are the VMs?
Host.
These are the hosts, okay.
Mock VM. It's what a VM on the host, create on the host. Okay.
Also, can you go over how to debug through our logs? Open up our logs and kind of go through how to debug through it?
Open what? Open.
The server logs.
Server logs. Okay. Server logs. Open. So by default, the log is in here. It's our manual server log.
And the configuration file?
Which configuration
The
file?
log4j config file.
Log4j is in okay. Let's go. See.
So we actually pretty much use this very standard log4j configuration, and you can actually make changes to the log4j configuration while the server is running, and then we will our logs will adapt to that. I think the one thing that's kind of important about our log4j is this throwable renderer that gets that's at the very top of it. We use a lot of code injection, right? And we use cglib for that. And I don't know how familiar people are with cglib, but then when you use cglib, then the stack trace often gets a lot longer because there's a lot of cglib injected libraries. And what this cglib throw renderer does is it actually when it's recording the stack trace, it will throw out all those extra little cglib stack traces. But if you want to see it, then you want to remove this class, and then it will actually put those in. But usually, majority of the time, they're kind of useless. Yeah, can you take a look at the logs?
Yeah.
And by the way, we used to be called VMOps. That's why it's called VMOps.log.
You can change.
And it's not VMOps, by the way.
So usually you can search exception. Exception here. If you find, okay, what the kind of exception is what we last time we hit the exception when we attach the variant to a VM. So if you find this kind of a bug, you can maybe better to go through the logs and find out the exception, and maybe paste the exception log to our, maybe we have a wiki. We have bug data. It's in bugs CloudStack bug. What? It's so slow. Okay. And then machine is broken. So you will have the UI. So you can go to the bugs CloudStack.org and create the issue here. Attach and have a summary of the bug and attach the logs. Then we can identify the issue when you have any kind of error when you run in the CloudStack. That will help us to debug the issue.
Can you stay here for 1 minute? So for every job every request that comes into CloudStack, there's a job ID that gets issued. And in all the threat contexts, you will see that job-16. So sometimes the errors may not be as obvious as a no pointer. And if you really want to see what it is, that ID is returned back to the client. So can you show your client? Do you record that?
Client. I don't have a client. Client. Yeah. You mean the API client?
Yeah, I mean your test client.
Okay.
Do you record the job ID in the test client? Oh no. Okay. But it is recorded as part of the or returned as part of the API request. And so then you should be able to see, oh, this is the job ID I want. I can go onto the management server log and says, do a grep on job-16, 18, whatever, and see how that flow through.
Let me see. They should have something. Test case result. No, here. All right.
Okay. Can you find the deploy VM log?
Right.
So here you see it says it is submitted as job 17. And this deploy VM is exactly that sequence I was talking about yesterday, where the executor thread does all of the creation in our database. And once it's created in our database, then we will submit the job down to the kernel and let the kernel starts take over to carry on the deploy VM. So when you look at this code here, you will see that it is the thread name that actually received that request is actually HTTP 8080-6. That would be a Tomcat thread, and you can grab that thread to see what happens before the job submission. Because if it failed during the job submission, then it would be somewhere in this thread. And once you see that, then you should be able to see the job executor 14, which is a different thread pool that picks up the job from the database queue and starts to execute it. And we can walk through that a little bit. So I don't know how much you guys recall from yesterday's talk about the sequence flows. But as you look through this particular log, then you will see we would transition the VM from stop state to starting state, right? And then we will call the deployment planner down at around 1108, 110008, the deployment planner allocation algorithms, which then tries to find a host and a pool for this particular VM. And if you keep going, and then the deployment planner. So actually, let me get up there. So I'm not tall enough. Can you bring that down a little bit? Bring it down. Thank you. So right here, we are calling the deployment planner allocation algorithms, right? When we call the deployment planners, we will tell it where we want to deploy to, but at the same time, we will tell it what you should avoid. Because in CloudStack, if one particular start doesn't work, then it will go back to the deployment planner and says, give me somebody else, give me a different host, or give me a different storage pool. And then and when it makes that call, it actually puts into the avoid list and says, well, give me back something, but this time don't use anything that in the avoid list that we gave you. So on the retry, then the deployment planner is responsible for making sure that whatever it returns is not in the avoid list. And when you come down here, this is where the deployment planner, someone was asking me about how the host allocator is being works. So then the deployment planner will call the host allocator and says, I found the clusters. Now you need to find me a suitable host. And if you keep going down. Keep going down. Yeah. So our host allocator is one of the most verbose logging mechanisms there is. Keep going.
Storage.
Yep. And then once it's past the host allocator, then it will look at the storage pools and says, well, I'm going to deploy to this cluster. You need to find me a storage pool that works in there. And if that didn't work, it will repeat that process. So it's possible for people to have set up hosts but hasn't set up any primary storage yet. Then it will need to work on that. It will need to do that again. And so keep going down. Okay, right. So
For network.
So right here, now yesterday I was showing this particular component, virtual machine manager, that calls the network manager. And the network manager looks at the network and says, this network is already implemented, meaning that we already have VLANs and things like that to support this particular network. So then, and it will move on to inform the network elements that has been configured on this system and says, look, this VM is about to come into the system, and you need to prepare whatever you need to prepare on the network. Keep going. So right here, you went a little too far. Now, if I jump 8 feet tall, right here. This manager right here is the implementation of our virtual router. It got asked as a network element by the network manager and says you need to prepare. And since in this deployment, and the virtual router is the major service provider for VMs, it needs to do work. So one of the things it's doing is it needs to start a router because virtual routers are deployed on demand, and so then it goes through the process of starting that router before it goes back to CloudStack and before it goes back to network manager and says, oh, the network is ready. So now you see this. It says job 14 applying the DHCP entries to my router. And then now it is sending this particular command. And this command is the JSON that I was talking about, where the virtual network appliance manager is sending it down to the resource and says, you need to add this DHCP entry to the DHCP because when the VM comes up, you need to issue this IP address to the particular VM. And so now this is quite important when you're doing debugging. And at this point, remember we actually have a barrier between our resources and the management server, even though they are deployed together in the management server process space. They are done by two different thread pools. They are done by two different thread pools, right? Well, what we do is we actually send this out, and another thread pool will receive this particular command. And the way that you see who received it is by following this sequence ID. So you will see right here that it is received by a different thread, and then this thread then goes and says, oh, I'm actually adding the DHCP entry into the router. And the response is now received back by the same thread that has the job 14, and now you can continue on to take a look at what happened on that particular thread. Any questions?
So the discover process in the beginning, all that data is from the database, or it does probe the resources?
Well, in the discover process, actually, it looks at the URL, right? So what will happen is that the send server URL, for example, the send server discover, for example, will say, well, I don't understand this URL because it only has sim in front of it, for example, right? And that discover will say, I don't understand this, and I cannot give you any resource back. When we reach the simulator discover, the simulator discover looks at it and says, oh, I understand that. And then it returns then in that case, it becomes a factory in our code that returns an instance of a resource. All right, so then, and I mean, in CloudStack, we also have the idea of being able to configure the password for that particular template. If the template has an agent that supports configuring passwords, and so then, and after the DHCP entry is done, then we will send a safe password command. So there's a lot of things that gets done here. And you can see we also send it to a bunch of other network elements in our space. And finally, we get down to actually trying to create the storage volumes. So can you actually go back up a little bit? Yeah. So then, and virtual machine manager, our network manager says, I'm done. And virtual machine manager will call storage manager and says, look, you need to get me the volume that's required here. And the storage manager will go talk to the template manager and says, well, I'm creating this volume on the primary storage. do you have a template already there? And template manager is basically saying, no, it's not. So it's trying to create in this storage pool, and the template manager says, I don't have a template there. I am now going to move on to actually downloading the template from the secondary storage to the primary storage. And again, this gets sent down to the resource because the data path of copying it is actually down at the resource level, not at the management server. So it needs to be sent as a command down to a resource to talk to the actual hypervisor to do the copying. And at the end, the download completes, comes back to this thread. This thread will then says, I am going to create the volume, and now I am going to start the VM. And you can see everything that's needed for creating the VM is actually passed down in this particular command because we expect the resource not to have any access to the database to get any information that it needs. So everything needs to be in this command. And so that's why you see this big block of things. And I mean, that's the great thing about JSON. You can read everything, but it's actually pretty long. Better than XML, but...
How does the JSON actually get to the remote agent?
How does it get to the remote agent? Okay. So when it is inside, when the resource is inside the management server, it's pretty straightforward, right? It's just a message passing between threads. That's pretty straightforward. But what we expect is that a lot of times the resource that are in a different data center than the management server may be protected by a firewall. So the agent container that project that we were showing is responsible for making a call out to the management server from within the firewall. And then establishes that TCP connection between the management server and the remote agent. And when we send these commands, and that is through that TCP connection, and then the agent will deserialize the command and into a class, and it calls the resource with that class. So actually, that's we can you bring up the Eclipse and bring up one of the agent commands. So let's bring up the start command. Yeah. So basically, the start command contains this transfer object, which is passed through all of our the virtual machine in startup sequence. And can you bring up send server Citrix resource space? Yeah, that's the one. So Citrix resource space is the one that I'm mostly familiar with because I helped write it. But actually, just go up a little bit more first. Go to execute request.
So many.
Yeah. So in a server resource, all it really has is something like this. An execute request, it takes a generic command, and in here, then it can parse out the ones that it understands and says, I can execute those. But if it can't, then at the very bottom of it, there's an exception that's thrown that says, I don't understand why you're sending this command to me. And so the start command was one of the things that's being sent. And so resources it doesn't want to know how to do the serialization, deserialization. It just wants to know how to map this particular command down to the actual APIs. And you can see here for send server specifically, we actually talk to the SAPI service. And these things here would be the SAPI services objects. Okay, well, we can go back to the logs. Yeah. Can you use sorry.
You said if the agent is behind the firewall, need to make a connection to the management server and has to maintain a persistent connection to management server all the time.
That's right.
Then you have a lot of agent, you're going to have a lot of connection, permanent connection to the managing server.
It is possible, but sorry, now I forgot to bring it. So it is possible. If you have a lot of agents, then there's a lot of TCP connections. And one agent can map to multiple resources. So you don't actually have to do one resource, an agent a resource. So it does not mean one TCP connection per resource. It could be all done through one TCP connection. But that's really kind of up to you because we don't really care about the agent itself. We only care about the resources underneath. So when the agent connects, it will say, oh, I have the following resources, and we will know to use that TCP connection. So if you want to, if you don't think the TCP bandwidth for one is enough, and you want to start up multiple Java processes and segment your resources that way, that's also possible. Okay, so where are we? So we got the start answer, and now we're actually gonna go tell the components that's interested that this VM is now complete, and finally at the very end we have the async job is complete, and at that point, if somebody is querying for this for the status of this job, they will get the actual status. Yes, button on the bottom. You need to QA this process. So Chandan is our star QA engineer.
Yeah, this is a question pertaining to the Citrix resource-based .java class, where I saw a method execute request. Are the methods inside that are specific for Zen server only, or is it like? Because I see a method something like set up firewall commands, which we usually don't run on ESXi hosts.
Right. But it does get sent down to, well, the setup firewall is for a security group commands. So VMware does not understand security group. That's why it would not have it.
So is that class specific for Zen server only? Is that what you meant?
Well, the collection of commands that a resource can support is basically up to that if-else list that it has. And then it's up to the hypervisor guru on top who says, oh, it can support it or not, and make sure it sends the command down or not. Okay.
So do I properly understand you that agents can run as a standalone project, standalone process?
That's right.
And do you expect agents running close to hardware or close to management server?
The agents will be close to the hardware. Yeah, we expected it to be in the same data center as the hardware.
And each agent will keep connection to the management server.
That's correct. Yeah, so the agent actually maintains a heartbeat with the management server, an application heartbeat, on top of the TCP connection as well. So when it gets disconnected, or when it times out, then management server will whack the TCP connection, and the agent also contains logic that knows to reconnect.
And agent connects to the server through the same servlet that clients connect?
I'm not sure I understand. What clients?
No, okay, your browser, for example.
Well, to the same IP address, but they're different ports.
A different port.
Yeah.
But it uses the same HTTP protocol.
No, so the agents actually connect using just regular TCP. There's no HTTP there.
And if you have a management server that's running in high availability mode, or you have like multiple ones, how do the agents decide which
So
management server?
you will have to put a load balancer in front of those management servers and let the load balancer decide where to put the agent connections.
So when you make changes to one head, it doesn't replicate back to, if in a cluster management server application or installation, you have to make these changes across the board to all the management servers, right? It doesn't back to the DB, or
Are you talking about the XML files?
or like the modification to these jars and other components of the management
Oh,
server.
yeah. I mean, you could put them on a shared drive and have all the management servers use that, but if not, then you have to make them.
You have to make it manual.
That's
Okay.
right. And there's reasons why you wouldn't want to put them on the shared drive either, because I think someone was asking me yesterday about how to upgrade in CloudStack when you have multiple management servers, right? So our process is mainly to bring down one management server, bring it up with the new code, and at that point you don't want that new code to be at the old management servers. So the new code, when you start up, then CloudStack will check the database and says, oh, has it been changed? Is it an older version? Is this database version fit to run this particular software version? If not, then it will go through a DB upgrade process. And as it goes through that DB upgrade process, when it completes, then that server can now serve requests, and then you would bring down another one and bring it back up with the new code, and then you bring down another one and bring it up, and on the very last one, that one will execute the cleanup code for the DB upgrade process. Yeah. So we can actually kind of show you that. Can you bring up the XML file? And I think I have a hard stop at somewhere, so let me keep track of the time. Oh wait, is it up there? Yeah, so 11:37. So we have a hard stop at 11:50, right, Dave? Okay. Can you let me know?
This one?
Yeah. So right here. So in this XML file, there's a list of what we call system integrity checkers. So in CloudStack, none of the management servers or any of these definitions are started until we've passed every one of these. And what we do here, the very first one you see is the database upgrade checker. So this one, it verifies whether or not the database is at a version that works with this software version, and if it doesn't, then it will do the job of upgrading the database. And then, for example, we have a lot of questions about encrypting things that we store in the CloudStack database, and the ability to actually generate a secret key so that you would encrypt those things. And so there's also a checker for making sure that the encryption key is stored and it is the correct encryption key to access that database before you allow the management server to proceed, so that you don't go corrupting data because you got the wrong encryption key. Yeah, so I don't really know why there's a database integrity checker. We have to go find out what that is. Somebody added that. And the management server because each management server has its own unique ID. That is to generate that ID to make sure we know what management server is at what IP and things like that. Okay. Yeah, so since we're here anyway, so we can take a look at the adapters. Yesterday, my little zoom-in was flying all over the place. You can take a look at the adapters that we have defined. And basically, in this XML file, at the top here, it says, oh, this is the management server class that's being used. These are the libraries that is being used. And can you bring up the libraries? The premium component library. Now, I mean, in any software where you have to put together your components together, right? But a lot of times, most of these components don't really change. It's not a case of everybody would make changes to every single manager in the entire system. So we basically put it into this Java class so that if you do any refactoring, you don't have to go to the XML file and make changes. And that's what this does. If you're interested in knowing what is the actual implementation of a certain interface, right? This is where you go to. You go to this library and see which manager, which info actually works on the interface. And then in the XML file, we basically specify that class as as a library. But down here, at this level down here, what we're doing is overriding whatever is in that library. So you could actually specify another manager in this class, in this XML file, and if it matches the interfaces that was specified in that library, the one in the XML file is the one that gets loaded into CloudStack. And you don't necessarily have to change this components.xml. It is possible to create a different components.xml, and you reference this particular components.xml. Do you have that? Or? No, I think we took off premium ever since we moved to open source.
Simulator have the simulator.
Yeah, so up there it says, oh, I'm extending the management on server. So in that case, we would, by default, whatever we cannot find, we will go to the components.xml there. But whatever is here overrides whatever is there. So we load them in that specific order. Now there's also a environment variable you can set at I think called component spec. Can you bring up environment.properties.in? Yeah. So yeah, right there. So if you set that, then we will actually look for that XML file and use that as the default, and then follow the chain up to find all the classes that you don't want to override. So it's possible to do things like that.
Special.
Yeah, so that's about all I have.